Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
When the deep universe was visible through the James Webb Space Telescope's reflectors.
Member of the James Webb Space mission, I asked her if it was worth the effort.
Clearer views of well-known cosmic history were anticipated by scientists. Rather, it produced pictures that defied everything we believe to be true. Webb discovered a galaxy that shouldn't be there. At a moment when the universe ought to have been chaotic and dark, a large and mature system shone.
The ingredients of the galaxy and the universe, and we on Earth are just a tiny part of that.
It seemed as though reality was concealing a second layer, and the deeper the web was explored, the stranger the cosmos seemed. Even physicists were unable to explain the data, since something in the far-off universe was violating the rules so severely. The first galaxy was impossible. I realize that you two are the first persons in human history to see these pictures. Most astronomers anticipated the typical indicators of early cosmic growth, such as half-formed clusters, chaotic gas clouds, and the rough beginnings of a structure still forming. When the James Webb Space Telescope captured the light of a far-off object designated as a baby galaxy. Rather, the scientific community was astounded by what the telescope revealed. The galaxy was only 290 million years after the Big Bang, which ought to have been much too early for the cosmos to contain any fully developed systems. The most reliable models of galaxy formation were contradicted by this finding. The universe was still cooling after its explosive beginnings at that time, according to conventional cosmology. It was only recently that matter began to group together. A massive, luminous galaxy shouldn't have formed and shone with such intensity because there shouldn't have been enough time, pressure, or stable areas of space. However, the data revealed a structure that appeared fully formed and mature, almost as if it had completely avoided the growth stages. What caused? The object's exceptional brilliance made the discovery even more difficult to explain. For its age, the galaxy's light emission was much brighter than expected. Due to the delayed and uneven formation of their stars, early galaxies often generated faint, scattered light. Webb found the contrary. The clear, constant brilliance that pervaded the entire system suggested the existence of a sizable population of stars that were already stable and well-developed. This was the first indication that the object didn't live up to expectations. Another surprise came from deep spectrum scans, rather than the young, unstable stars that were anticipated throughout that cosmic era. Older star populations with distinct chemical signatures were present in the galaxy. The formation of these stars should have required hundreds of millions of extra years. The conventional time frame of star evolution was directly challenged by their appearance. Our existing knowledge of early star cycles may be lacking if these stars were actually as advanced as their signals suggested. The thick clouds of gas and dust that ought to have enveloped such a young star were also absent from the galaxy. Due to their continuous accumulation of residual stuff, galaxies in the early cosmos were disorganized and unstable. There was hardly any evidence of this thing, of that rubble. It appeared as though it had created stars with every atom at its disposal, leaving only pure starlight in its wake. No natural process has ever reached a 100% gas-to-air conversion rate in current observations, as indicated by that level of efficiency. Today, even the most active starburst galaxies are only able to turn a small portion of their gas into stars. One revelation was not the end of the shock. The telescope discovered dozens more galaxies exhibiting the same implausible characteristics as the scientists extended the search farther into the same area of the sky. For the era in which they were built, these structures were excessively large, light, and well-organized. They started to be described as foreign in internal reports. Structures because their behavior did not match any of the predictions made by established physics. Astronomers discovered they were not examining isolated anomalies as they scrutinized the rising amount of data. They were looking at a pattern that had implications for the universe's whole narrative. This is not how the universe ought to appear. Another set of signals emerged as scientists sorted through Webb's observations, pushing the puzzle well beyond the discovery of early galaxies. These signals originated from locations that ought to be outside the Hubble sphere, the boundary where galaxies accelerate away from us due to cosmic expansion. Based on accepted physics, beyond that line, light ought never ever to reach Earth. Before it has a chance to go across the enormous cosmic distance, it should fade and extend eternally. However, Webb captured distinct characteristics that linked to areas where light ought to be permanently imprisoned. This discovery immediately caused worry, since it suggested that there may be a fundamental difference between the conventional model's predictions and the behavior of space-time at extreme sizes. In order to explain why far-off objects appear dimmer and farther apart as the universe expands, cosmic expansion equations were developed. According to Webb's detections, there may be areas where these rules fail or behave differently. The limit may not be as rigid as scientists formerly thought if light from outside the Hubble sphere is reaching us. This made cosmologists think about the idea that space might not expand uniformly in all directions. A number of physicists were interested when additional data was received. They started challenging the widely held belief that all matter, time, and energy were generated in a single explosive beginning of the universe. The early timeline has previously been called into question by the discovery of completely formed galaxies nearly at the beginning of time. Uncertainty was further increased by signals coming from outside the purported boundaries of the observable universe. If these signals were real, they could indicate an older or different, ordered universe as opposed to the one that the conventional Big Bang hypothesis describes. According to one theory, the early universe had expansionary stages that differ from the straightforward narrative that is currently taught. According to this theory, the universe may have expanded unevenly or halted in between phases, which could cause odd distortions in the way light moves over long distances. A timeline inaccuracy, which suggests that the universe's structure began far earlier than current models anticipate, was put forth by another group. The entire cosmic timeline would be altered if the initial galaxies were older than anticipated. A more speculative theory suggested that space-time might have a fracture zone, a boundary where two cosmic regions overlap or press against one another is described by this idea. We may be able to see a part of space that is typically hidden because the signals picked up by the Webb may be passing over this barrier. This theory matches the peculiar behavior of the signals and explains why the light appears to originate from inaccessible areas, despite the lack of verified data. Cosmologists were compelled by these discoveries to reconsider the notion that the universe expands in a straightforward, smooth fashion. Rather, it may exhibit the characteristics of an uneven or stratified system with subtleties that were not evident to earlier telescopes. As boundaries became hazy and timelines disintegrated, online started seeing increasingly odd patterns, signals that shouldn't be there, hidden deep within the background noise. Webb caught something even more difficult to explain at a time, when scientists were still debating early galaxies and inaccessible areas. The telescope picked up a gentle, repetitive oscillation deep beneath the faint hum of the cosmic background. The team was able to anticipate the next pulse before it happened because the signal repeated at exact intervals. Because it appeared to be a constant cosmic pulse concealed behind all other noise in the cosmos. This peculiar frequency came to be known as the heartbeat beyond time. Many initially thought it was a calibration error or interference from Webb's instruments, but the pattern originated in outer space, according to many tests. After dissecting the pulses, scientists discovered that the intervals matched well-known mathematical ratios, such as harmonic sequences that may be found in domains such as wave physics and quantum systems. Some scholars suggested that this might be a natural resonance brought on by the density or form of the universe. Similar to how a stretched surface can create recurring ripples, space can vibrate under specific circumstances. Others, however, noted that the accuracy was excessively precise. This signal remained precise down to the smallest quantifiable unit, whereas natural processes typically exhibit modest variance. This degree of consistency led others to speculate about the potential of an encoded structure or a pattern produced by an unidentified substance. It will make scientific breakthroughs that cannot be achieved in any other way. Webb saw another oddity in the far-off universe as this controversy intensified. Strong gravitational lensing, or the bending of light around distant galaxies by their gravity, was observed in a number of them. Their apparent mass could not account for the strength of this bending. This imbalance is typically explained by dark matter, but the distribution did not fit any model or simulation. Rather than creating a smooth, the gravitational effect manifested as distinct patches in the halos surrounding galaxies, resembling unseen hands pressing down from above. Because it behaved like gravity from an invisible source unrelated to known dark matter fields or conventional matter, researchers started referring to this phenomenon as phantom mass. The problem is that the human eye cannot see infrared. This was not an isolated instance. Webb noticed such abnormalities in several other areas. In places where there was no light, no dust, and no detectable particles, each one indicated the existence of something substantial or powerful. Some experts speculate that these aberrations may result from higher dimensional effects that some advanced physics theories anticipate. According to these theories, unexpected pressure can be created in areas devoid of matter by gravity leaking across dimensions. Confusion was increased by another abnormality. A thin light signature from the end of the observable cosmos was tracked by one of Webb's instruments. The signature vanished entirely for a moment, as though it had vanished behind something. It reappeared moments later with the identical spectral fingerprint. Light typically stretches and changes in predictable ways as it moves across the universe, so this was odd. A light beam may have bounced off a surface or barrier if it returns unaltered. Global observatories recorded the recurrence and categorized it as potential proof of a cosmic system that is either closed or somewhat bounded. This theory suggests that rather than being infinite and open, the universe may have a reflective layer or an edge. Because such a structure is not included in any common cosmological model, with anomalies growing from all directions, the idea of a limit existing far beyond what is typically visible startled the scientific community. Once impossible explanations began to be put forth by theorists. The theory of the mirror universe. One theory became more prevalent within study teams as the odd data kept coming in. It implied that we might not be alone in the universe. Alternatively, it might have a physical twin that grew alongside ours and traveled in the other direction of time. Although this concept is not new, it was given new life by recent JWST findings. Scientists observed that the rotating patterns of some distant galaxies defied expectations. They whirled in patterns that seemed to indicate the existence of an opposing force, as if their motion was being influenced from somewhere else by an invisible partner. Furthermore, it does not appear to be a spiral galaxy or an elliptical galaxy. Something much more peculiar was discovered by teams researching high-energy particles. In different parts of the sky, they saw paired movements that matched one another. It couldn't be a simple coincidence because the reactions were too coordinated. According to the research, particles in our universe may be reacting to changes in a hidden environment that is right next to us but is invisible. It was dubbed a shadow environment by researchers. This phrase served to characterize an area that is comparable to ours but still unreachable. Significantly increased the emissions of over 3,000 old galaxies that were previously undetectable. Gravitational models strengthened the concept when researchers used simulations. The findings revealed minute gravitational pulls on our universe, suggesting the potential consequences of an invisible universe that travels backward in time. The odd distortions that JWST had been capturing were consistent with this tugging. Overlapping gravitational waves from a mirror realm could be the cause of the phantom mass fields that bent light without revealing any observable objects. The strength of these waves would be insufficient to separate planets or stars. They would only leave faint but discernible traces in the fabric of space, which is precisely what the telescope captured. Another group investigated how light from far-off objects behaved. A portion of the light that arrived, JWST, seems to have chosen a course that was out of step with the surroundings. Before the light reached us, it seemed to pass through an invisible area. The concept of a boundary zone resulted from this. This zone might theoretically be a tiny layer where the two universes meet. Light may convey conflicting information from both sides if it manages to pass through this shared border. This could account for the disappearance of a long-distance light signature and its subsequent reappearance with the same spectral fingerprint. It acted like a beam striking a reflective surface at a big object's edge. Simulations that included all of these discoveries started to yield even more fascinating outcomes. When researchers, impossible galaxies suddenly made sense when they incorporated a mirror universe with opposing time flow into their models. Our world might be under pressure from a twin universe, hastening the development of early structures. It also got simpler to explain the cosmic background's regular heartbeat signal. It might be the outcome of coordinated action between two cosmic worlds that have been linked from the beginning of time. Although the theory is still theoretical, it fits more facts than anticipated, which makes it difficult for scholars to disregard. However, a different theory casts even more doubt on everything. There are roughly 5 billion people in that galaxy, light years in the future. Thus, we're looking back 5 billion years at indications of a clash between dimensions. An increasing number of cosmologists think there may be indications of something much more dramatic than a mirror world in the universe. They contend that JWST might be detecting signs of a physical intersection between two worlds. This theory is based on a variety of odd data that defies easy placement in conventional cosmology. Together, the patterns create what some scientists refer to as the initial phases of a cosmic intrusion event. This theory revolves around the impossible galaxies discovered by JWST. They seem too big, too developed, and too well organized for the time period in which they appear to be. These galaxies might not even be part of our universe, according to some experts. Rather, they could be the final remnants of an earlier cosmos, the boundaries of which are slowly moving into our line of sight. JWST is not seeing early cosmic history in this scenario. Seeing alien material from a universe with an entirely different lifespan is what it is.